Alright, for problem number 21, we're asked for the critical values. The critical values are simply when the derivative is equal to 0. So we got the derivative is 3x squared minus 48x plus 28. And when we try to factor this, it doesn't work. So we're going to use the quadratic formula. And so we got 48 plus or minus 48, negative 48 squared, because this was negative 48, minus 4 times 3 times 28 over 2 times 3. So we have 48 plus or minus the square root of divided by 6. So negative 48 squared, and put this all in my calculator, and we get 1968. So I got 48 plus 44.4 and 48 minus 44.4 divided by 6. This one turns out to be 15.4, and this one turns out to be about 0.6. And those are the critical values. For this particular problem, we want to find out where the graph is decreasing. So in order to figure out decreasing, we first take the derivative, which is x cubed minus 24x. And then I'm going to set this equal to 0, so I factor out an x. So I got x equals 0, and x squared minus 24 equals 0, which means x squared equals 24, and for the purposes of this one, I'm going to leave it as the exact answer of plus or minus the square root of 24. And so I'm going to go from negative infinity to negative square root of 24, from negative square root of 24 to 0, from 0 to the square root of 24, and from the square root of 24 to infinity. So I'm going to pick a really big negative number like negative 10. I know that this is around negative 4 point something. And so I'm going to pick a negative 1 here, positive 1, and 10. So when I plug in negative 10, I'm going to get a negative, and then this part is going to be positive, which means that this is part of my answer, which is decreasing. When I plug in negative 1, I get a negative and a negative, which is a positive. So that is increasing, and that's not the question. This question is decreasing. When I plug in 1, I get an increase and a positive and negative, which make a negative, which means this is going to be decreasing. And when I plug in 10, everything is positive, so this is positive, so this part is increasing. So this interval and this interval are my answer. So in problem number 23, we would take the derivative, 3x squared minus 12x minus 20. Once again, I made this so it didn't come out factorable. So when I do the square root of all of this, I get 12 plus or minus 19.6 over 6, which gives me x equals about 5.3, and x equals about negative 1.3. So negative infinity to negative 1.3, negative 1.3 to 5.3, and 5.3 to infinity. Negative 2, 0, and 6. When I plug in negative 2, I'm going to turn out to get a positive number into the derivative. When I plug in 0, it's a negative. And when I plug in 6, it's a positive. So, right here I have a relative max. Right here I have a relative min. So my answer is simply going to be 5.3 because we're looking for the x value. Alright, for this one we take the second derivative because we're looking for concavity. So the first derivative is this. The second derivative is 6x minus 54, which I'm now going to set equal to 0. So 6x equals 54 divided by 6. And x is equal to 9. So from negative infinity to 9, and from 9 to infinity are my intervals, and I'm plugging it back into the second derivative, 0 and 10. When I plug in 0, it's negative, so that's concave down. That's not what we're looking for. When I plug in 10, that's concave upward. So my answer is from 9 to infinity. So for this problem, I'm going to plug 1 into the problem first. So when x equals 1, f double prime of 1 is equal to 3 minus 12 plus 11, which is 2, which gives me a minimum because it's concave up. When x is equal to 2, I plug that in and I get the answer of negative 1, which means that x equals 2 I have a maximum, and at x equals 3 I get the answer of 2 again, which means it's concave up, which I have a minimum. Alright, limits at infinity. The highest exponents are the 3's. So my answer here is negative 2/3. Because we're even, and so we just need the coefficients. Alright, for this one we need the limit at negative infinity and at positive infinity. So the limit at positive infinity, well, on the top the square root of 16 is 4, and on the bottom 3 times a positive is 3. So my answer is 4/3 because the exponents will match up, because this is really going to be have an exponent of 1 when you deal with the square root and the squared. However, for the negative infinity, we got a positive divided by a negative, which means my answer is plus or minus negative 4/3. For problem number 28, we're starting our antiderivatives. So this is the same thing as the antiderivative of t to the 1/5 dt. So when I add 1/5 times plus 1, I get 6/5. The reciprocal in front plus c. For problem number 29, we got x to the 5th over x squared plus x cubed over x squared, which means I have x to the cube, third power plus x dx. So the antiderivative of x to the third is 1/4 x to the 4th. The antiderivative of x is 1/2 x squared plus c. Alright, for this particular problem, we're trying to find out what f of 1 is. So I'm going to use this one right here, because it's got the or equal to sign. So we got 3 minus 1 squared, which is 2, and that will be all for this video.